In this exercise, we'll use Autodesk Inventor to improve the design of a Formula SAE race car wheel so that it's lightweight but strong enough to withstand acceleration loads. The wheel center is part of the subassembly. To analyze the wheel center, you open the part. The first step is to create a simulation in the stress analysis environment and apply the loads and constraints that the part will experience during use. To test the part as currently designed, we'll start with a baseline simulation that uses a single point design objective and the default settings for static analysis. The first step is to apply the required material to each part. In this example, the aluminum 6061 selected in the part environment is correct. It is possible to override the default material for a simulation to test and compare results using different materials. Under safety factor, there are two options. For this simulation, safety factor is calculated using yield strength. The next step in the workflow involves selecting the loading, constraints, material, and contact values to apply. The wheel center has 10 radial arms that are bolted to the wheel rim, so pin constraints are required on all 10 holes. In addition, a frictionless constraint is required on the face of the hole where the drive shaft is bolted to the wheel assembly. A moment load is applied around the axis of the hole. For this simulation, we'll use 130,000 Newton millimeters. This is typical of the moment applied during acceleration. The simulation can now be run. We're looking for a minimum safety factor of 2.0 so that the design is built to safely handle 2 times the stresses caused by the maximum expected load. The yield strength of the material is 276 MPa, so for a safety factor of 2, the maximum stress can never exceed 138 MPa. The maximum stress value is 23.54 MPa. The maximum displacement is 0.06325 millimeters. And the minimum safety factor is 11.68. To determine the mass of the design, you exit stress analysis and open the part. As we can see in the eye properties of the part, the mass is currently 1.143 kilograms. To visualize the effects of the force, re-enter the stress analysis environment and animate the simulation for the stress, displacement, and safety factor results. With von Mises stress active, the color red is displayed on the part. This indicates areas of maximum stress, but does not necessarily mean the design will fail. To view the color display against your design criteria, the color bar settings can be modified. Changing the maximum value to the material's yield strength clearly shows that the current maximum stress is well below the allowable value. Also, the part's displacement, shown by the bending radial arms, is exaggerated to make it easier to visualize. The actual displacement is very small. You can select from a list of values to suit the needs of your review. In conclusion, we are safely within the design requirements. It is likely there are modifications we can make to reduce the mass.